Hello boys and girls, welcome back. Using what we learned about scientific notation and using what we learned about laws of exponents and combining them and multiplying numbers with scientific notation that are in scientific notation. Alright, so our objective for today is I will be able to multiply numbers in scientific notation. Please, boys and girls, make sure that you are writing these notes in Cornell style. Go back and look and make sure that you are doing it correctly. From now on, I'm going to be starting to take points off about your style of notes that you are completing these in. Alright, so multiplying numbers in scientific notation. So multiplying in scientific notation requires at least 3, sometimes 4 steps. So step 1, multiply the coefficient. Step 2, multiply the powers of 10. Step 3, combine these results. Step 4, put them in proper form. Alright, so let's see an example of that in action. So I want you to evaluate 6 times 10 to the 4th power times 2.5 times 10 to the 2nd power. So step 1 is multiply the coefficients. So 6 times 2.5. And 6 times 2.5 is 15. The next step is to multiply the power of 10s. So 10 to the 4th power times 10 to the 2nd power. We know with our exponent laws that that's 10 to the 4 plus 2 power, which is 10 to the 6th power. Then you need to combine those results. So now we have 15 times 10 to the 6th power. Now, as you recall, the coefficient has to be in between 1 and 10, so 15 isn't proper. So we need to put that in proper form. So we need to move that decimal one place over to the left, and when we do that, that turns into 1.5 times 10 to the 7th power. So that's our final answer, 1.5 times 10 to the 7th power. Let's see another example. So now we have 2 times 10 to the 3rd times 3 times 10 to the 5th. Alright, so first step, multiply the coefficients. So we have 2 times 3 is 6. The second step is to multiply the power of 10s. So we have 10 to the 3rd times 10 to the 5th. When you add the exponents, you get 10 to the 8th. Combine those results, so we have 6 times 10 to the 8th. And do we make it proper? In this case, it already is proper, so 6 times 10 to the 8th is our answer. Alright, our next example is 9.2 times 10 to the 5th times 2.3 times 10 to the 7th. So first we need to multiply our coefficients, 9.2 times 2.3, which when you multiply that out, you get 21.16. Then you multiply your base 10s, multiply the power of 10s. 10 to the 5th times 10 to the 7th is 10 to the 5 plus 7th, which is 10 to the 12th. Then you combine those results. So we have 21.16 times 10 to the 12th. And last but not least, we need to make it proper because 21 is not between 1 and 10. So when we make it proper, we get 2.116 times 10 to the, and not 12th power, but 13th power. So let me fix that, 10 to the 13th power, because we have to add 1 when we move it, the decimal point over. Alright, another example that we have is 3.2 times 10 to the negative 5th times 1.5 times 10 to the negative 3rd. It's the same exact thing, even though we have negative exponents, we still need to multiply the coefficients first. So 3.2 times 1.5, which is 4.8. Then we multiply the powers of 10, so 10 to the negative 5th times 10 to the negative 3rd, which negative 5 plus negative 3 is 10 to the negative 8th power. Combine them, which you get 4.8 times 10 to the negative 8th, and it's already in proper form. So the answer is 4.8 times 10 to the negative 8th. Alright, so I need you to write down your 2 questions like we always do, and we will discuss this further in class when I see you next. So thank you so much for actively listening and taking good notes, and I will see you later.